Topic is, can general hospitals compete with specialty hospitals? This is syllabus for this video. Our objective is, first, discuss the various types of hospitals that comprise the hospital. Second, figure out correlation between patient attributes and charges for hip and knee replacements. And third, do estimation and prediction of charges with patient's information provided. As we all know, there are a lot of differences between general hospitals and specialty hospitals. Many hospitals in USA are general hospitals, and they provide a broader range of diagnostic, treatment, and surgical services for patients with a variety of acute medical conditions. As for specialty hospitals, they only provide limited types of services and admit only certain types of patients with specific illness or conditions. Since specialty hospitals may raise the bar for quality and encourage general hospitals to implement quality improvement strategies to compete effectively, they are able to offer patients better amenities and achieve higher patient satisfaction. Therefore, our projects focus on whether specialty hospitals can compete with general hospitals through analyzing discharged data from real world. The dataset we got from hospital healthcare website called the Statewide Planning and Research Cooperative System Inpatient De-Identified. It includes discharge level detail on patients' characteristics, diagnosis, treatments, services, and charges in 2002 with all the hospitals involved in New York State. To analyze it, we select one specialty hospital called NYU Joint Hospital and 5 general hospitals in Manhattan, with a number of cases from these 2 types of hospital and 2 types of surgeries, knee and hip. Algorithms we used are listed here. For analysis, we use ridge regression, random forest regression, and for prediction, we use ridge regression, linear regression, tree, and neural networks. Here comes the analytic results. First, let's look at some correlation between patient attributes with numbers of going to different hospitals. Due to aggregation of the patient's data, we can see from the table that older people more than 17 tend to general hospitals for replacement. As for different races, white people tend to specialty hospitals for replacement surgery. Secondly, let's visualize the charges per day of general hospital and specialty hospitals to see the difference. We use histogram to show it. A specialty hospital costs more than general hospital. Length of stay in specialty is longer than general. No wonder that total charge of specialty hospital is more than general hospital. Next, we want to figure out the correlation between severity level between different types of hospitals. We can see from the graph that the more severe it is, the patients tend to go to specialty hospitals. Here is the ridge regression parameter for each feature of patient. Let's go through each feature that might influence charge of general or specialty hospital. Positive means this feature improves charge, while negative means this feature decreases the charge. Black people tend to general, while white people tend to specialty. As for type of admission, elective represents appointments ahead of surgery. We can see if patients choose appointments, it will charge more than other type of admission. Next feature is patient disposition. It is about how patients will be treated after they discharge from hospital. We can see that if patients choose self-care, it will charge more money, while skilled nursing home will charge very less money on both general and specialty hospital. This is the result for ridge regression represented in Jupyter Notebook. We can see the error rates, feature importances, and the percentage of illness here. In order to help patients to better choose a hospital, we do prediction about the total cost on 2 types of hospitals. We use 4 machine learning algorithms to do the prediction, splitting the data into test and validation sets. We use a function score to numeric to change all categorical data to numeric data while reading the data. Also, we change all columns to integers so that we can do regression and classification to the data set. Since the data we use is raw data, we choose 2 types of feature selection method considering the sparsity of the data set. Besides, we tested the difference between using principal component analysis and without using PCA on the rows. So these are the two types of feature selection methods we used. And here we use PCA to do dimension reduction. Considering the runtime of selection, we choose only two types of selection, variance selection and tree-based selection to do validation. We build models and put all the prediction error rate in the table. We can see that feature selection can reduce test error rates, especially tree-based selection can significantly improve the performance of a tree. PCA can be used to reduce dimensions to avoid deviated data, but the size of training data will also be decreased. The differences between linear regression and ridge regression is very slight. We also tested neural networks on Amazon AWS using Sienna with the following parameters, but the performance is very poor with test error rates 81.25%. We constructed an MLP and have the following cost function using gradient descent. But we can see with different parameters, it still cannot have a great performance. So this is the test error rates. So finally, we choose tree-based feature selection and tree for regression to predict the total cost. With input data, we can recommend a type of hospital with the estimated cost for two types of hospitals. By giving all the analysis and prediction, we can make a conclusion that white people tend to specialty hospital for replacement surgery. Old people more than 17 tend to general hospital for replacement. Specialty hospital charges more than general hospital, and we can use tree-based selection and dimension reduction to train the model. Given the new information, estimated cost of these two types of hospital can be calculated by tree model. And by using this analysis and prediction, our project can help patients to better choose a hospital he wants. Thank you.